So from the schedule, we're right on track. We're in chapter 2 today. We're going to have 2 parts to it. I'll introduce that. Next week, we're going to work through chapter 3, which is mean, median, and mode. So that's variation, position, those kind of things. Our NumWorks calculator that we'll have either downloaded to your smartphone or a tablet or on the computer. We'll show you how to use that to do all the calculations, but we'll also look at the formulas and the way it's calculated. We'll start with that today. We have a data review, and then we've got our exam. Practice test will actually be available by next Thursday. It might even already be there, but I may revise it a bit. So my goal, if you can work through next week through chapter 3 over that weekend, maybe go through that practice test, you'll know whether you're ready or not, or what your questions are. And September 2nd, that Tuesday, we can spend, it will be kind of like an open lab day. So you can get any questions answered, any homework, whatever you need. We'll do a little bit of review, but most of it is, best review is actually doing work. So we'll do that. Any questions? All right, let's go ahead and move forward. So, and I'm hoping that you find if you keep up with the steps that we're doing, everything builds on itself. Nothing becomes too complicated. And it might even seem easy at certain times because we're taking small steps. Math gets difficult if you miss a bit and you've got to go from the first floor to the second floor. That's hard to jump a flight of stairs. But going up one step at a time, it's a much nicer way to go. These days, I even take one step, a double step. I don't, just to keep my balance, right? So let me introduce what I'm doing today now. So we're going to get into chapter 2, so new material. There's really just one lecture. So what I've added for the second part is something I wanted. When I taught this last in spring, I decided at the end I wanted to use Microsoft Excel, or in this case, we're going to use Google Sheets to do some of the calculations because it was really helpful. But I hadn't taught anyone how to use it earlier on. So that's what we're going to do today. I'm going to describe how to do all the calculations, and then I'm going to show you how to do it using a Google Sheets table. It says in Excel, but it's not really in Excel because Google Sheets is a little bit more accessible. What I'm going to do, it's got an EC in front of it. What do you think EC stands for? You got it. So by doing these extra credit activities, which I'll try to add one maybe each chapter we go through, maybe not all of them, but in this case, that's what I'm doing because it's extra work on top of the homework. However, it should really help. So the extra credit overall will be 2% of the grade. So you can earn 2%. What that'll do is it basically rounds you up to the next level. So if you're close to getting an A but not quite there, that 2% will get you there. To be honest with you though, if you do all the extra credit, you probably won't need it. It's one of those things, if you do it, you'll learn it and you'll do great on it anyway. You don't really need it. So, but it doesn't hurt, right? It doesn't hurt to have a little extra credit added at the end. So we'll do that. And the extra credit is just something, when we get there, I'm going to walk you through it and I'm going to record it. What I'm going to encourage you to do is pull up the sheet and have the video running at the same time, and you can do it because what it's designed to do is just to teach you how to pull up the formulas, and you can do just basically going through it, you're going to get it right, okay? But that's what we're going to look at doing. Okay. So instead of talking about it, let's just do it, right? Okay. So we're going to do something called, we're going to build a frequency table. What does the word frequency mean? Frequent, happens a lot, or yeah, how many times something happens. There's a radio frequency. That's how quick the waves are moving, but it's basically a count of how often something happens. That's a frequency. So that's all we're doing. We're looking. We could use this for both qualitative or quantitative data. Doesn't really matter. The example you're going to see, we'll use a quantitative one, but in the homework they've got both of them. Then we're going to look at creating graphs, both histograms or bar charts, as well as a pie chart. And then the second part of the class will follow up with using Excel to actually do everything we did in the lecture by hand. Okay, and then that way, when you go into the homework, you could use a spreadsheet just like we're doing to do the calculations. You could use a calculator, but I believe once you go through the extra credit activity, it'll all make a lot of sense. Okay, so first, here's what is a frequency distribution. Well, we have a list, like a raw listing of data. And instead of saying, each data piece could be a little different. So instead of saying there's one of each, what we do is we group them into classes. So we have no idea what this data is, but it's somehow going from the numbers 1 to 30. I don't know what those are. We'll look at ones that are. But what they've done is they've grouped them into class. So what we know is this frequency over here, number 5, say, what that is telling us is that in this class, so the numbers 1 through 5, they occur 5 times. Now, we don't know which one. They could be all 1s, they could be all 5s, they could be a mix of 1, 2, 3, 4, 5. We don't know, so we lose detail, but at the same time, we get a look of the overall data and say, oh, there's 8 here and 8 here, so those guys are the most in these 2 classes. So maybe we want to focus on these because they happen the most, or something. It might give us an idea of what's going on with this process. So that's why we use a frequency table instead of looking at just a bunch of raw data, right? Just a bunch of numbers. And when you add all the frequencies together, the number that you get is the total amount of data. I'm going to start doing this. I'll put n equals. So we use the letter n to stand for how much is in the sample a lot of times when we get down the road. So n equals, that's the sample size, okay, number of pieces of data. So when you total the frequencies, you've got to have the number of data. So it's a way to check out things, and we'll see how we do that. So we're going to talk about, we're going to look at a set of data. We're going to make our frequency table. We'll talk about how to get these class boundaries, these class limits, and how to create it. Okay. So we see we have what they call a lower class limit, the bottom side, and then there's an upper class limit. So it's telling us, like for that first one, that first class has numbers from 1 to 5, inclusive of 1 and 5. That's typically how they are. If the number is 6, then it's over here. And it's also indicating it's probably discrete data, because otherwise you might, well, what if I had 5.5? Which one would that go into? Well, I probably don't have 5.5 because otherwise I would have to set my classes up separately, right? Those numbers between 5 and 6 are not in there, so it must be discrete. Kind of indicates that. Class width, so what you can do is you can take the lower limit of the first class, the lower limit of the second class. If you subtract them, that gets you your flat class list. And think about it, or class width. Going from 1 to 5, if you just subtract them, you get 4. But if you count them, because 1's in there, right? So that's 1, 2, 3, 4, 5. There's 5 potential items that are in that class. That's why I like using my fingers. You can physically see 1 through 5 is actually 5 things. So it's got a width of 5. And then the other thing, we're going to see how we get all of this. We need to know the range of the data. And the range is simply taking the biggest piece and subtracting the smallest piece of data, maximum minus the minimum. That'll give us our range. And we'll do that calculation, and then we'll be able to get our class size. So here's our data. I guess it's just raw data. What I've done is I've also taken that same data, copied and pasted it into a Google Sheet so that when you go to do that activity, you don't have to enter the data. Eventually, we'll get you a place where you'll enter the data, but I want you to focus on how to analyze it. So this is our raw data. It's 30 adults, so we know there's 30 pieces, and you can see 3 columns. If you go, there's 10 or 3 rows and 10 columns, so there's 30. And they would like us to make a frequency distribution, which is that table, with 7 classes. Now, why 7 classes? It's not a big, it's the number of classes we do use just depends on what we want to look at. Okay, if you get more classes, you get more detail, right? But sometimes that could get busy because there's a lot of bars. If you have fewer classes, it's less busy, but then also less detail. So it's, find that sweet spot. How many do we use? In this case, they've asked for 7, so we'll do 7. But there's no hard and fast rule for how many classes you use, except I think one of them said maybe somewhere between 5 to 20. You don't want too many, otherwise it's like way too busy. And you don't want too few. If you only had 2 classes, you'd get 2 bars and it might not tell you too much. So let's see what we're going to do. You decide on the number of classes that was given to us. Oh, here it is. Usually we do 5 to 20. They told us 7. Find the class width. We're going to do that. Find the largest, smallest, divide by the range of the classes, round up to the next convenient number. So we're going to start off with this. Here's our data again. Again, what we're going to see is this is not really technically hard, but what's hard about this is it's tedious, and you've got all these data, and you've got to pick the smallest and the largest. And if you're like me, sometimes you miss it. You pick the wrong one. Oh, that wasn't really the largest. It was a big one. But so we're going to see how the Google Sheets will use a function, and it will make sure. So it's a good way to check on things, as well as if we have more than 30 pieces of data, the more data we have, it's just harder to deal with it. So that's where technology comes in here. So number of classes, we were told 7. So find the class width. The way we go about finding the class width is we find the largest, and you'll see 405 is the maximum. There's 400, but nothing bigger than that. And then 155 is the smallest. And the reason I was able to pick those off so fast is I've been spending the last 2 days working through how I was going to do the spreadsheet. So I've done this several times, but it might take a little bit of time, right, looking at those. So to find the class width, we take the maximum minus the minimum, and that will give us the range. So we do that. That's 405 minus 155. And again, I can do that pretty quick because I've done this. It's 250. Again, you could either do it mentally with a calculator, however you want, but what we've got is our range is equal to 250. Oops. Let me and then we're still not at the class width yet. To get the class width, what do? Divide it by 7. Literally, we are dividing it into 7 groups of data, right? So we take our range. I'll just do it this way. Divide it by 7. Plug in a calculator. And I use our numworks. I'll show you the numworks probably in 3 because we're going to use it a lot. But for here, I'll just do it this way. 250 divided by 7 gives us 35.71. And what we're going to do is we always round up. Even if it was 35.01, we would go up to 36. Okay, if there's a little bit over 35, we always round up to the next one, just so we have enough space and everything. So what we're going to see is our class width. We're going to use is 36. Okay, so far so good. Okay, no questions yet. Good. Please, if you got questions, just ask them. Holler out. It's okay. We're just working through this together, okay? Because it's usually better, because then if you forget, then we don't know what the question was, or you got lost, and it's a lot easier to get you back on track if you let me know right away than at the end and have to go over it. It's all rounded. I mean, it's all recorded as well, but that's why I do that. So round up to 36. Okay, now what we need to do is we need to find those class limits. Remember, the lower limit to the higher limit. And so these are the steps, and again, we'll do it. We start with the minimum piece of data, because we don't need to go below the minimum, do we? It would all be zeros anyway. So we can start with the minimum, which in this case was 155. That'll be our lower limit of the first class. What we then do is we add the class width, which was 36, right? From our particular data, we're going to add it to the lower limit of the first class, and that will become the lower limit of the second class. Okay, kind of in words is a lot, but we'll see. Then we're going to subtract 1 from the lower limit of the second class, and that becomes the upper limit of the first class. It's a lot easier just to do than to say, to talk about, but there's instructions there. Well, here they did it. Okay, so you start with the first one. You add 36 to it. 155 plus 36 gives us 191. So that gives us this part. To get this number, you take the 191, subtract 1 from it to back up, and that gets you the upper limit of the first class, so 155 to 190. And then what you get for the rest of the numbers is you just, with these numbers started off, is you just start adding 36 to the upper limit, and that gives you 226. Add 36, you get 262. And on this side, you're doing the same thing. You just keep adding 36. So notice you have to kind of treat the lower limits and the upper limits separately, but from one to the other, it's always 36. That's that class width. And then you'll get all your classes when you get to the maximum, or something, in this case, a little bit past the maximum, we can stop, because all the other classes would be empty, right? There's nothing bigger than 406. Actually, nothing bigger than 405. So that's how we know when to stop. And because the way we've done it, we also know to stop after 7 classes. But notice this mathematically will always work out. It will include all our data. Now, so we okay so far? And again, we're going to get Google Sheets to do this. It's a little complicated in the formulas. You have to remember a few things, but again, that's why I'm going to record it, and you're going to do it from the recording. And if you forget about those things, you do what I did, is you just Google it, and somebody else has a video out there that tells you what functions to use. That's how we do things these days, right? University of YouTube. Okay, so if we're good on that part, yeah, so they're talking about this a little bit overkill, right? We subtracted 1, we got that one. You add them all together, kind of what I did. So this is the tedious part. So now that we've got our classes, we just need to figure out our frequencies. And what we do is we look for all the data from 155 to 190. Well, there's a 155 there, so I'll cross it out and put a tally. And then I keep going. Oh, there's a 165. That's in that class. So I'll put a mark there. I'm not going to do this for all of them, so don't worry about that. Here's a 168. And I keep looking. That's the last one. So there's 3. So that's how they got the frequency of 3. You keep doing that for each of these. And again, doing it by hand is just tedious, and it's easy to miss one, or maybe to count one twice. It gets real messy. So that's why we're going to use the Google Sheets. But I just want you to see it's not hard. It's just tedious. And it's easy to make a mistake. But one way we check our mistake is, once we have our frequencies, you have to add them together to make sure you end up with 30. So if you've got 30, that's probably good that you got everything in the right place. But again, when I'm going through these, sometimes I put 1 in the wrong class, or I miss one or I count one twice. Those kind of things can happen. Okay, but technology will help us get rid of that. But as far as the process, does that seem fairly straightforward so far? Okay, so this is the first part of getting the frequency distribution. We've got our classes, we've got our frequencies. Sometimes when we want to report, notice, because like I said, we don't really know, it's got a width of 36. We don't know whether they're at the beginning or the end. So one way to characterize data is to take these classes and then look at them as if they were actually a point. And so we use the midpoint, the middle. So the way you always get halfway through 2 points is you take the lower plus the upper and divide by 2. That gets you halfway between them. So if you take, I don't think they do it here, but so for the first one, 155 plus 190 is our first class. If you divide that by 2, you'll get the midpoint. And I think we've got it. Oops. Let me back up. Let's do that real quick. So 155 plus 190 is 345. 345 divided by 2 is going to be 172.5. So that would give us the first midpoint, and you do that for each of the classes. And we'll see, we'll do that with the Google Sheets as well. And we could use that to represent that bar on a bar chart, or we could use the lower limit, or I guess you could use the upper limit. Sometimes you'll see them with the classes listed different ways, okay? But we'll look at this table. The other thing that is oftentimes helpful, we have the frequency and an amount of number. But if we want to compare this data, a sample of 30, to some other sample that's maybe larger or smaller, say a sample of 100, what would be helpful is to have it as percentages rather than amounts, right? Because if you have 100 pieces of data, you're not just going to have 3 in that first class. You probably have some more, but to be able to compare them to see if they're similar, what we do is use percentages, okay? Relative frequency. To simply do that, you take the frequency of the class divided by the sample size or the total. So that first one, there was 3, and we divide it by 30. What's going on here? And you get 10%, or you get the 0.1, which you could also write as 10%, and we'll show you. I like percentages. They look a little prettier than a decimal, but again, it'll do that for us. And then another thing that's sometimes helpful is what's called a cumulative frequency, which is just, I call it the running total, right? First one had 3, and then you add the next one to it. You just kind of keep a running total, and you just keep adding the next one to it until the very last class will always have a frequency that equals the sample size. So in our case, it's going to equal 30. So let's just take a look here. Let's do all that. Okay, here's the magic. Boom, it's done. Well, here's all the calculations behind it. And again, we're going to automate all of this with Google Sheets. And I'm going to use this exact same example. So if you want to come back and take a look at this, you can always check the answers, right? Which is always helpful. Again, what I want to focus on is the process. And so this is the final thing we're going to have created. So we counted these frequencies. We started here. We did get the midpoints for each of the classes. We've got a relative frequency, which remember is a percentage. So 0.1 multiplied by 100 becomes 10%. So we can do each of these as percentages. So they always add, if you leave them as decimals, they add to 1. You turn them to percentages, they will add to what? You have everything. What is the percentage that means you have everything? 100%. Okay, good. So you actually can't have more. Well, I guess you can on some things, but so we would have 100% there if you did it as percentages. We'll see how that works. And then the cumulative frequencies, again, this just starts the first class, you just copy it over, and then you take this 3 plus the next frequency, 3 plus 2 is 5, and then you take 5, 5 plus 5 is 10, 10 plus 6 is 16, so that you've got a total running down here. So sometimes you could do a quick look of who spent less than 299 minutes or something. We could go here. Oh, 16 people or less than that. Okay, so it just gives a quick way to look at things. So far, so good. Okay. I think that's pretty much it. That's what we're going to do today. We're also going to have the tools make frequency histograms for us. So we're just going to talk about them. In fact, actually, what time is it? It's 9:30. We got plenty of time in here, so we'll see how we go to the next one. But a frequency histogram is simply, just think of it, it's a bar chart where we're going to turn it into a visual. So on the what's this? That's the vertical axis. I get these confused. Vertical axis is going to be the frequency as a number or percentage. We'll do both. And then on the bottom are the data values. With a histogram, the bars are supposed to touch. If they're not touching, we call it a bar chart. We could use probably either one. We can do that. Usually, we set the class boundaries so they touch. We're going to see, we're not going to worry too much about this because the way we use these Excel sheets or the Google Sheets, it will take care of this for us. But just so you're aware, a class that goes from 155 to 190, so just so the boundaries, if you want to print it, you subtract a half from the bottom, you add a half to the top. That can give you your class boundaries. But again, since we're dealing with discrete data, there is no number between 190 and 191, so I'm not too worried about this part. In fact, I'm going to kind of skip over it. I just want to show you that that's there because some people might use that someday. So if you see things talking about class boundaries, you just go a little bit above, a little bit below, and so that it includes everything. Okay. That's how you calculate. You subtract a half and add a half so that they're touching. We're going to see that these are really easy to create once we have a frequency distribution table set up in Google Sheets. You just insert a table and copy things over. It's pretty straightforward, and it will work through getting all of this. But you can see it's got the frequency here, and so you can see this bar here that represents, and again, they're using the midpoints here, 316.5. There was a frequency of 7. And we're not starting at 0, so they put this little broken axis. We're not really, again, going to have to worry about that. You could also label them with the I see the difference between these two. You can label them with the boundaries, and we'll do both of those in Google Sheets. But again, a lot of this is just dependent upon what you want to do. Mostly what we do these things for is if you're doing a report, you need create these visuals because a visual, you can see, oh, it goes down and then it kind of goes up, and you see trends, overall trends of what's happening. And especially for a presentation, it's a lot easier just to look at a nice little chart and see the picture. You catch up that pretty quickly. You look at all those numbers or even a frequency table, just a bunch of numbers, it's not going to be as meaningful as a picture. So and then we'll show you can basically copy and paste, and you can have a nice, beautiful report done. And again, they say, one thing you do is look at here at 260. And again, this is just a random thing they picked up that Oh yeah, there's about 2/3. There's a lot more over greater than 262 than less than 262. Um, and since it's a picture, you can sort of visualize. Yeah, maybe it's about 2/3, um, but certainly more than half. Okay, that's what those are good. Frequency polygons. I'm going to tell you what they are, but I don't like them, um, and I don't think we have it in the homework either. But what they've done here is these data values are the midpoints. So these points are the midpoints that we would have calculated. And then instead of having the bars, what they've done is they've connected them with lines. The reason I don't like it is to me, it's misleading, because then you think that these lines between the points are meaningful and they aren't, right? This is really taking a histogram that should be a bar chart. When we look at it as a bar chart, well, they're supposed to touch, but we'll do this. We just know that there's a bunch in that space, but we don't know exactly what they are. But when you look at this frequency polygon, it looks like these are actually data values, which they aren't. They're just the midpoint. There might not be any data actually at that point. They could be much lower, much higher. And, but it's used for trends. But, if you're going to look at trends, I would come back here and I could see the trends here. I like these because they're accurate. This, I think somebody made up, and I say that it's an idea that should have been thrown away a long time ago. But anyway, it's here because other people disagree with me. I'm not always right, but I always have my opinions. Okay. So they're going to ask us to draw a frequency polygon. We won't go into too much detail on doing it by hand, because if you ever need to do it, use technology. It's going to look beautiful. You're going to be able to copy and paste it. We can't publish things too much by hand anymore. We could, again, once you construct the histogram, the polygon is just taking those midpoints and connecting it, and then you erase the histogram, you erase the bars. But again, it's inaccurate, because you follow these and you're used to going, okay, this is an important point here. No, it's not. It's just that these two are connected, right? So these connecting lines really have no value, and even the midpoints were a calculated thing. It shows an overall trend, but I'd rather look at the bar chart. We're going to see that. We're going to use technology of our own. Relative frequency, we're going to see that all we do is we're going to take that percentage instead of the value. So instead of, like, that first data point was a frequency of 3, but it was a 10%, we're going to use 10% instead of 3. So we use the relative frequency for the units rather than the frequency. And so what you see is the only change is that these over here are percentages rather than amounts. But the chart itself, you can see that it's got the same shape, right? Because it will. But this is now something we could use to compare to another sample, because its sample size really doesn't matter here. We've got percentages. So we take a larger sample, a smaller sample, and we can see, do we get about the same percentages, or are there differences, So percentages are helpful. And we'll see, we can, with a couple clicks of the mouse, we can change one from an amount of frequency to a relative frequency. Okay. And there they are side by side, and you can see they're very similar. It's just, the scales are a little different, but it gives you the same part. Pie charts, the pie, the circle, represents what? How much? 100%. So what this is going to do is then take each of those items, break them into a slice. You can do this by hand, but I wouldn't. Why when the tools will do it for us? The way you could figure out sort of the degrees is, how many degrees is in a circle? 360, right? So you take 360 times the percentage, and that will tell you the angle of the interior thing. But who's going to take out paper and protractors and all that stuff when we're going to see Google will do this for us, or the Google Sheets. So here's an example where it's helpful to do it like this. Here's, again, qualitative data, right? It's how many people have an associate's, a bachelor's, a master's, or a doctoral degree. We have the numbers in thousands. What you would do is you get the total, and then you would get the relative frequency for each. And so they did that. Here's the relative frequencies. They took that relative frequency, so to get that angle of 91.8 degrees, they took 360 degrees times 0.255, and what they would get would be 91.8 degrees. And that's for an associate's degree, and it's, it's a little bit more than a 90-degree angle. Hard to tell on that. But again, what we're going to use using technology, we don't have to calculate the angles. It will do it for us. But it all started with a frequency table. So if we can make it a frequency table, then we can use our tools to make various graphs. Again, this I don't particularly care for, but it's just to make it pretty. A Pareto chart, and I'm not even sure where that word comes from. This is the only place I've heard it. All it is when you have qualitative data, nominal qualitative data. Do you remember what is the difference between nominal and ordinal? Anybody? Nominal, ordinal. Which one has order? Ordinal, right? So it kind of has, ordinal has order, but nominal does not have an order. So since nominal does not have an order, all a Pareto chart is say, well, since there's no order, let's put it from largest to smallest, or smallest to largest. You could do it either way, just so that it looks pretty. That's all it really is for. So here's an example. Number of people in, see, what was it? Leading cause of death. Again, there's no order to these accidents, cancer, all these different things. There's no real order. These are just causes. But just to make it look pretty, they started with the one that has the most first. And so it sort of does an ordering, right, by which one happened the most. So even though this is by itself not ordinal, unless you were to say, these are the top 5 causes of death, and then now they're ordinal. So it forces an order on things. Okay, so when you see Pareto chart, that's just going to force the order on it. Again, I don't think there's any in the homework. If there is, you could probably do it fairly easily, but I don't think we have any of these. There's one. The last question has you do a scatter plot, and that's just, it's going to have you plot some points. So we're going to do this more later on. It's called regression, and it's when data is paired. So there are always 2 parts to the data, and it's something a little different. But again, you could do that last question, or if you skip it, you'll still have over 90%. So there's only one question that even gets onto this. So I'm not going to spend much time, because we will spend a considerable amount of time on scatter plots down the road. So we can kind of skip over. So it'll look something like that. But and then time series charts is just a type of a scatter plot. And again, we get to this later on when we're going to do some scatter plots. And all the difference with the time series chart is that one of the data is time. So you get plots over time. But we're going to address all of this later on. Yeah. And that takes us to the end of chapter 2. And we've spent enough time. I'm going to stop this, and then I'm going to record the next session separately.